Namaste, welcome. Today we are going to discuss about kinematic equations for uniformly accelerated motion. So this is very important in motion in straight line. Actually, here equations in the sense we will derive three equations. Kinematic equations are three. Among them, in this particular video, we will derive the first kinematic equation, or even we call it as equation of motion. Okay, kinematic equation or equations of motion. As I said, the first equation of motion we are going to derive now. For that, what we need is, we need to consider a uniformly accelerated motion. So, what we do is, we'll just consider a body is moving with a uniform acceleration. So, let me consider A, small a is the acceleration. Small a is acceleration, and I will consider the body had an initial velocity of v0. So v0 is the velocity which is initial velocity. Initial velocity. Okay, and I'll consider the final velocity is v. V is the final velocity. Okay, and I will take t, that is small t, as the time taken to have this change, that is from initial velocity v0 to the final velocity v. In time t, the body accelerates with an uniform acceleration a. Okay, so to derive the first equation of motion, what we need is, we need to draw a velocity time graph. Okay, velocity time graph we have to draw. For that, you can refer back if you want what is velocity time graph. You can understand in the previous videos I have explained it. So along y-axis we represent velocity. Okay, velocity time graph means the y-axis of the graph we are representing velocity, and along x-axis we are representing the time. Okay, so here, as we have understood, a is the acceleration, v0 is the initial time, v is the final time. So what I will do is, I will plot a graph for this situation, and let me consider v0, that is the initial velocity as we have considered, and final velocity, that is when the body reaches a distance, it will be having a final velocity v, and the time taken, the corresponding time here, that will be, this time will be t. Okay, small t, as we have considered. Now let me join this point, that is v0, to this perpendicular line, so that I will get a triangle here and a rectangle here. So I will name the points as O, and here A, B, C and D. Okay, for my convenience, I have given some names. It should not be the same. You can change it. Okay. So what we do now is, in order to derive the first kinematic equation or first equation of motion, we consider one of the feature of velocity time graph. From velocity time graph, as we know, the slope of the graph gives the acceleration, isn't it? The slope of the graph gives the acceleration. So I will consider that particular factor and I will try to derive the equation. So, slope of the graph is equal to acceleration, or I will write the acceleration A is equal to the slope of the graph, isn't it? So I'll write it, slope of the graph means the slope of this line AB, line AB's slope I need. So how I can get it? That is, slope of this line would be BC divided by AC here. BC divided by AC. So here, what is BC? What is this BC? BC, this length. See, along y-axis we have this point as V0 and this point as V. So the difference, this BC should be equal to this, right? So this will be V minus V0. So what is AC then? AC is this. AC is this, so this is parallel to this and is also equal to this distance, that is nothing but T, isn't it? So V minus V0 divided by AC is T. Okay, you understood, I hope. BC is V minus V0 and AC is T. This is equal to A, acceleration. So I will just rearrange it so that I can bring this T to the left hand side, and A into T becomes equal to V minus V0. Okay, so again rearranging, what I'll get is I'll take V on the left hand side and the remaining things on the right hand side. So V equal to V0 plus A into T. This is what you call as the first equation of motion or first kinematic equation of motion. Okay, this is the first equation of motion. It is very important. We will be using this so many times while solving problems, and we'll apply this in so many situations. So here, as we know, V is final velocity, V0 is initial velocity, A is acceleration, and T is time. Hope you understood it.